Hello, this time AC Ohm's Law Level 2. In fact, the problems here are not that different or more difficult than the Level 1 problems. It's just that inductors are used more often. Here, what value does the resistor have? Well, once again, we can note that the 330 milliamps of current and 9.9 volts of voltage is all we need to know. We don't need to worry about the phase. However, I should point out something at level 2 here that may confuse you if you're not looking out for it. For a resistor, the phase of the voltage across the resistor is equal to the phase of the current going through the resistor. So how come this voltage here has a phase of minus 45 degrees, but the current has a phase of 135 degrees? Well, the answer is that this voltage, if you look at it carefully, is sort of upside down. The plus symbol here is on the bottom, the minus symbol there is on the top. So this end of the resistor is at a higher AC potential than this end of the resistor. So this minus 45 degrees would actually represent the phase of a current flowing this way, up the resistor, which is the opposite direction to the direction of the current that the ammeter is reading. That's why the ammeter says 135. It's the opposite phase to minus 45. If something was at, if we draw kind of a phase thing here, 45 degrees would be up here, and the exact opposite to 45 degrees, caused by the fact that the ammeter is measuring the current in the other direction, so in effect minus 330 milliamps. The opposite phase down here is minus 135 degrees, which is why those two things are different. Anyway, it's a resistor, so we don't really have to worry about that stuff. We know that the resistor is real. We know the magnitude of the voltage across it and the magnitude of the current through it, and that's all we need to know to work out the resistor. We just take the 9.9 and divide it by 330 milli, and we're done. Okay, this one you've got to be on your toes a bit, because the question is asking you for the magnitude of the voltage and not the actual voltage as a phasor. So the phase is irrelevant here. It just wants the magnitude of the voltage, and the magnitude of the voltage we could get just from good old V equals IR, where the magnitude of the voltage is the magnitude of the current times the resistance R, so that would just be 1 microamp times 27K. If you entered a complex number in here, it would say syntax error, can't understand, because all it's expecting is a real number, just the magnitude. Next. Here we have an inductor. Let's do this one. What value does the inductor have? Well, V equals I, and the impedance of an inductor is J omega L. So we've got that equation now. We know what V is. It's 11 volts at minus 90 degrees. And again, since all I want to know is the value of the inductor, I'm just going to look at the magnitudes of things. The magnitude of J is just 1, so I can forget about it. Magnitude of V is the magnitude of I times the magnitude of the impedance of the inductor, and the magnitude of the impedance of the inductor is just omega L. That would mean that L, which I know is a real number, is V divided by the magnitude of V divided by the magnitude of I divided by omega, which again is a real number. So that would be, the voltage is 11 divided by the magnitude of the current, 745 microamps, times 2 times pi times 5 megahertz, because that's the current operating frequency. So that's my inductance. Great. Just do one more. What phasor would represent the current source here? And, that's actually a little more interesting than it might at first appear, because we've got to be very careful at level 2 with the direction of the ammeters and the voltmeters and the current sources. And we know that the voltage across this inductor is 1.38 volts at an angle of minus 135 degrees. And that would be related to the current flowing through the inductor from the high potential end to the low potential end. In other words, if we wrote V equals I times the impedance of the inductor, J omega L, then V would be the voltage from here to here, and I, the current, would be the current from here down to here. But this current is flowing down that way. So that's the current flowing up through the inductor, which is the opposite direction to the current that we would get from this equation here. However, that just means we multiply by minus 1. Or, in other words, here, invert the phase. So we've got here a voltage of 1.38 volts at minus 135 degrees. And the current of that is going to be that times J omega L. So I could just write divided by J times omega times L, which is 220 microamps. And I could work that out, and that would give me 1.38 at minus 135 degrees divided by J times 2 times pi times 1 megahertz times 220 microhenries. And that should be my answer. Just either paste that up into here or just say X. Oh, except it isn't, because that is the current that's flowing down through the inductor this way, and the current flowing up would be 180 degrees in the opposite direction. So that would in fact be this lot, but the phase would be minus 45 degrees. And I could enter the answer like that. Alternatively, I could just say X times minus 1. Either would work. Okay, I think that's enough at level 2 to give you the idea. Good luck. Don't let the complex numbers get you down.